Alright, let's give this another shot. I'm going to play some Chat GPT math roulette. Just going to tell Chat GPT to give me a random high school math problem, and I'm going to try to solve it. Let's see what we get. Last time they weren't great. Okay. Let's get the question on the screen here. That's fine. Alright, so we're solving for x. So we got ourselves the equation 3x squared. Is that plus? I think it's minus 12x plus 9. I think that's what that is. Minus 12x plus 9 equals 0. Alright, so this is a factoring problem. And I know that it's a factoring problem because we have a quadratic equation, which is an equation that has an x squared in it, and that's the biggest exponent on the x. We also have 12x and a 9, so this is in standard form, which is when you have the x squared first term, and then the x term, and then the constant. So we have ax squared minus bx plus c here, which is a quadratic. The first thing you always want to look at when you're solving an equation like this is if you can factor anything out. And we can factor something out. We have a greatest common factor here. Every single term can be divisible by 3. So I can take a 3 out front. And that's going to leave inside, if I divide every term by 3, I get an x squared minus 12 divided by 3 is 4. X and then plus 3. So all I did was factor out a 3 there, and that's a really useful tool here because now we don't have a number in front of this x squared, which is going to make it much easier to factor. So this equals 0. So in terms of solving this equation, we can kind of forget about the 3 because we're trying to figure out what x equals, so we can divide both sides by 3 and the 3 just goes away. Because if we divide by 3 here, 3's cancel, and no matter what you divide 0 by, it's still 0. So the 3 just goes away, and we're left with this equation right here. We want to factor this, and the key to factoring is going to be to find two numbers that add to the middle term and multiply to the first number times the last number. Oftentimes in school nowadays they use this X method where you are looking for numbers that multiply to a times c, so the number in front of the x squared and the last number, which is just 3 times 1, which is 3, and numbers that add to this number, which is negative 4. The first thing you want to think about when you're factoring here is what the signs are on the two numbers. So we know that they have to add to a negative number and multiply to a positive number. So in order to multiply to a positive number, the signs need to be the same. They don't necessarily have to be positive, but if they're both negative, that would make a positive number as well. In order to add to a negative, obviously we're going to need some negative aspect. So we know that both numbers have to be negative because that's how you multiply to a positive and add to a negative. There's no other way to do that. So now that we know that both numbers are negative, we're looking for factors of 3 that add to 4. There's only 2 factors of 3. We only have 2 options here. It's 3 and 1. So negative 3 and negative 1 are our numbers that we're getting from this little thing that we're doing over here. And what this does for us is gives us the numbers in the factors here. So the way you set this up, factoring is breaking this equation into 2 separate equations that are multiplied together here, each of which has an x out front. Since we have no term out here, we don't need to do some of the harder steps that might happen in factoring, and our terms are just x minus 3 and x minus 1. At some point I'll get into what we call that factoring with a leading coefficient. When there's a number out front, things get a little more difficult when that's happening. So this is our factored form, and this makes it easier to solve this equation because we have two things that are multiplying together that equal 0. So if either one of these things was to equal 0, then the whole thing would equal 0, right? Because no matter what you multiply by 0, it's going to equal 0 no matter what. So now we can set both of these little terms equal to 0 and solve our equations, and that should give us our answers. So we got x minus 3 equals 0 and x minus 1 equals 0. Again, because if either one of those terms equals 0, then the whole thing equals 0. And to solve this equation, we just add 3 to the other side. And the answer is x equals 3 here. And here we're adding 1 to the other side. The answer is x equals 1. We can check both of those to see if they work. I'm just going to check the 1 because that's sort of easy to plug in. Let's make sure we did our work right here. So if I plug 1 in here, we get 3 times 1 squared minus 12 times 1 plus 9. Well, 1 squared is just 1, right? Times 3 is just 3. Minus 12 times 1 is just 12. Plus 9. Does that equal 0? Well, 3 minus 12 is negative 9. Plus 9 cancels out, and that's going to equal 0. So those are our answers. X equals 3. And x equals 1. And that's how you factor with a leading coefficient of 1. Thanks for watching. Catch you later. Alright, I'm going to say that at the end of every problem that I do because I'm going to cut these into smaller videos for anyone that might be watching. Alright, let's see what else Chat GPT's got for me. Clear the frame here first. Cool. Alright, let's see what our new question is. Alright, framed up nicely. Okay, so the problem is a rectangle has a length that is 4 times its width. If the area of the rectangle is 100 square units, what are the dimensions of the rectangle? Okay, so let's draw a rectangle just for reference. I'm not sure that's to scale, but that's the best I'm going to do for now. For the sake of the problem, so it has a length that is 4 times the length of its width. So length is 4w. So let's call this the width. And then the length would be the other dimension, which we know is, we could call it L, but we actually know in terms of W, so we only have one variable, that the length is 4 times the width, right? Okay, and then we know the area is 100 square units. Let's put an A equals out here. Cool. And the formula for area is length times width equals area for a rectangle, right? So we can do the length times the width, which is 4w, our length, times another W, and that should equal our area, which is 100. Cool. To simplify this side of the equation, we get 4W squared. It's going to equal 100. And when you're solving an equation, you're going to do pretty much the opposite of order of operations, which is PEMDAS, if you've heard that before, parentheses, exponents, multiplication, division, addition, and subtraction. So we actually want to do division before we do exponents, and those are the only two things we have to do here. So the first thing we're going to do is divide by this 4. Again, we're doing PEMDAS in reverse order because we're solving an equation, sort of undoing the order of operations. So now we have W squared equals, because the 4 cancels here, and W squared is going to equal 25. And the last thing we have to do is get rid of this squared. How you do that is to square root it, which is just going to cancel out the squared, cancel out the square root. What we do to one side, we have to do to the other side. So W is going to equal 5. And that's our answer to that one. So W is 5, so our width is 5, and our length is 4 times 5, which is 20. So we got W, say L equals 20. And there it is. Another question. All right, let's run another one. New question. This one I'm telling it specifically to do an Algebra 2 problem. Let's see what it has for us. Systems of equations. I think that might kind of be Algebra 1, but we can do it. Okay, let's solve the systems of equations. Cool. So we've got 2x plus 3y equals 7. Actually, so we got 2x plus 3y equals 7, as well as 4x minus y equals, is it negative 3? Cool. So here are two equations. When you're dealing with systems of equations, there are 3 ways, I think, typically that we solve these. One of them is substitution. Another is elimination, and you can solve by graphing, which you'll see sometimes. This one, when I'm looking at it, substitution looks like the easiest one to use. So I'm going to show you guys how to do a little substitution. So this equation right here obviously has x and y in it, and the other equation has x and y in it as well. So we can't solve an equation that has two variables in it because we're just going to get one variable in terms of another variable. So we have to figure out a way to get rid of one of the variables. And one of the ways to do that is by solving one of the equations for one of the variables and plugging in the information into the other equation. So I'm going to do that with this bottom equation. I'm going to solve for the y. So I'm noticing that this y is all by itself. So if I add y to the other side, I'm going to be able to isolate this y if I can get rid of that -3. So I'm noticing that if I add y to both sides, I get 4x equals -3 plus y. And now again, I want to get this y by itself, so I'm going to get rid of this -3 by adding 3 to both sides, giving me 4x plus 3 equals y. And now that I have something that equals one of the variables, I can take this right here and plug this in for the y in the other equation. And that's where the substitution comes into play. We're substituting this thing that we made equal to y in for the y in the other equation. So that's going to give us 2x plus Alright, in order to solve this equation, we have to first distribute the 3 into the parentheses. We want to get rid of the parentheses first so that we can deal with everything else. So we're going to have 2x plus 3 times 4 is 12x plus 3 times 3 is 9. And that's going to equal 7. We can combine like terms on the left side of the equation, so 2x plus 12x is going to equal 14x. I don't know why I dragged out the 4 like that. 14, you know, and then we got plus 9 equals 7. And then I'm going to subtract this 9 over. That's how you solve an equation like this. It's going to equal -2, and as I feared, this is going to be a pretty ugly number. So now we just have 14x equals -2. To solve the rest of the equation, we divide by 14, which is going to give us a pretty gross fraction. -2 over 14. 2 and 14 have a common factor of 2, so I can actually divide both of these numbers by 2 to simplify this, but it's still pretty ugly. X is going to equal -1/7, and I'm assuming that y isn't going to be much prettier. So now that we have x solved for, we can use substitution again, substituting x back into either one of these equations. I think the bottom equation is going to be easier to solve, so let's go 4 times x, which we now know is -1/7. -1/7. And then minus y equals -3. And we want to solve for this y again. So we can actually kind of do what we did over here. Add the y to this side, add the 3 to this side. So we're going to kind of end up actually using this equation. So it's 4 times -1/7 plus 3 is going to end up equaling y. And then 4 times -1/7 is -4/7 plus 3 equals y. So y is going to equal 3 minus 4/7, which is going to leave us with 2 and 2/7. 2 and 3/7, sorry. And that'll be our pretty disgusting answer. If we plug these back in, it should work in both equations. We kind of just proved it with this one, but it should work with the other equation as well. And that's the answer. Thanks for watching. Catch you later. that's in. Let's do a couple more. I don't think that was an Algebra 2 question. Chat GPT really isn't spitting out very good questions for me. Maybe I'll try something else. Let's do some questions from the MTEL. What's this? All right, let's do this question from the MTEL. Set up. Okay, that's aggravating. I don't know how to do this. I need another monitor. Guess I could. All right, still trying to figure out how I'm doing these. Thanks for popping through, whoever popped through. It's me, CFD. Thanks for what's up? How you doing? Tort, what's going on? I think I'm gonna call it for this one. Got a few questions done. Not really the type of questions I'm trying to do. I thought Chat GPT Roulette was going to be a cool series, but Chat GPT doesn't give very good math questions, unfortunately. So that sucks. And I'm going to try and run through the whole MTEL. I just don't know how I'm going to frame it yet. I might hop back on later and try and do some of that. But thanks for hanging out for a second. I'll catch y'all later.